Let's begin today by doing a little bit of review of what we've covered so far. We talked about rational equations that are equations that have more than one rational expression, and we determined how to solve them. The first thing we want to do is find out, are there constraints? I cannot have a zero in the denominator, so those are going to be some constraints. I want to do those first. Then I'm going to clear the equation of the fractions by multiplying by my least common denominator, keeping in mind that I do need to check all my answers because I may have introduced extraneous roots in the process of clearing my equation of the fractions. Then we solve for the variable, and you always, once again, want to check your variable. Today we're just going to go one step further. We're going to do inequalities. They also contain one or more rational expressions, but instead of being equal, they're unequal. So we're going to follow the same basic pattern, determine any values that aren't possible where our denominator is zero, clear the equation of fractions by multiplying by a least common denominator, solve for the variable using our regular algebraic process. Keep in mind though that since it is an inequality, whenever you multiply or divide by a negative value, you need to flip the sign around. We're going to check all of our answers anyway, so even if you miss the sign up, it's not going to be a big deal because we are going to go back and double check. And we always want to check our answers, keeping in mind that when we do inequalities, we are checking ranges of values, not necessarily one specific value. And there's going to be multiple pieces that you have. So if you have two answers, you need to include your constraints here as a possible third break in your range of values. And you'll see that as we go through some examples. So let's do an example. Let's say we have this one right here. The first thing I want to do is figure out what x cannot be. X cannot be a positive 2 value. So I'm going to go ahead and state that x is not equal to 2. I'm going to look for my lowest common denominator. I have a 3, a 4, and an x minus 2. Multiple of 3 and 4 is 12. So I have 12x minus 2 as my common denominator. When I multiply each of those fractions by my lowest common denominator, I get the 3 and the 12. That reduces down to 4. So I have 4x times my x minus 2. In this middle fraction, I've got the x minus 2 piece, so I just need to multiply by the 12. Keep in mind that it is preceded by a negative. And then this last fraction, I have 4 in the denominator, so 12 divided by 4 is 3. So I have 3x plus 1 times the x minus 2. When I distribute all of those, I'm going to get 4x squared minus 8x minus 12 on the left, and then all of this on the right, the 3x plus 3 and the x minus 2. I went ahead and kept those together, and then I went ahead and distributed that. So I did kind of two steps in that one line there. Now I can get all my x squared terms to one side. In fact, I'm going to make this a standard quadratic. So I'm going to get everything over to one side. That gives me x squared minus 5x minus 6. And now I'm going to factor. When I factor, I get x minus 6 and x plus 1. So what are my values that are possible? If this were an equality, I would say, well, x could be 6, x could be negative 1, and both of those may or may not work. But since it's an inequality, I want to check ranges. I'm going to check where there's a break at 6, a check where there's a break at negative 1, and a break at 2, because I do have a constraint there as well. So I want to check those three ranges: values less than negative 1, values between negative 1 and 2, values between 2 and 6, and values greater than 6. So if you can imagine a number line or literally draw one out, I didn't draw one today, but I'm going to work out each one of those pieces. So I'm going to pick a number that's less than negative 1, such as negative 2. When I plug in negative 2 into my original equation, I end up getting a negative 5/12 being less than negative 1/4, which is true. So I have values that will fit when x is less than negative 1. Now I'm going to check between negative 1 and 2. I'll use 0. When I use 0, I get 1/2 is less than 1/4. That is false. 1/2 is greater than 1/4. So my values in between negative 1 and positive 2 do not work. Now I'm going to check a value between 2 and 6. Let's say 3. When I plug in a 3, I get 0 is less than 1. which is true. So I can have values between 2 and 6. And then I'm going to choose a value that's greater than 6. I could use 10. I've chose to use 7. So when I use 7, I get 2 and 2/15 is less than 2. That, once again, is false. So my final answer are going to be in the ranges where it is true. So that means x is either less than -1 or x is located between 2 and 6. Try this next one on your own. So solving for this one, I first of all notice that x cannot be equal to 0. I am then going to multiply by my least common denominator to get rid of fractions. My least common denominator is going to be 15x. So multiplying everything by 15x will give me 75 plus 18 is greater than 10x. Combining my like terms of 75 and 18, that gives me 93. Dividing both sides by 10 gives me 9.3. So there are a couple of values that I need to check. I need to check right around 9.3 and also at 0. So I have three ranges: values less than 0, values between 0 and 9.3, and values greater than 9.3. So let's start off with the ones less than 0. I'm going to try -1. So when I plug in a -1 into my original equation, I get -6 and 1/5 is greater than 2/3. That is false. A negative number is not greater than a positive number. Now I'm going to try a value between 0 and 9.3. I'll use 1. When I plug in a 1 in my original equation, I get 6 and 1/5 is greater than 2/3. That indeed is true, so that one works. And now I'll pick a value greater than 9.3. I'm going to use 10. So when I use 10 in my original equation, I get 31/50 is greater than 2/3, which is false. So therefore, my final answer is really only the values in between 0 and 9.3. Try this next one. All right, first of all, I notice that x cannot be equal to 0. I am now going to multiply by my least common denominator, which is going to be 9x. So multiplying each piece by 9x, my first term becomes 12, my second term becomes 63, and my last term becomes 5x. Combining my like terms of the 12 and 63, that gives me 75. Dividing both sides by 5 gives me x greater than 15. You could have 15 is less than x, which is the same as x is greater than 15. Now, I've got a couple of places to check. I do have a break at 15 and I have a break at 0. So I need to check values less than 0, values between 0 and 15, and values greater than 15. So if I pick a value less than 0, let's say -1, when I check that out, I get -7 3/4 is less than 5/9. That is true. If I choose a value between 0 and 15, such as 1 or even 10, I use the value of 1. I get 8 1/3 is less than 5/9, which is false. And then I chose a value that is greater than 15, something like 20, or I used 16. So when I use 16, you get 25/48 is less than 5/9, which is also true. So here we have a discontinuity of x is either less than 0 or greater than 15. Now that brings us to weighted averages. Weighted averages are when a certain value occurs more often in a list when you're trying to find the average than other numbers. As an example, let's just say that you made on a test, let's just say as an example, you took 10 tests throughout a semester. Out of those 10 tests, you had 9 of them that were 98%, and you had one test grade that was a 70. You would expect your grade to be closer to the 98% than you would the 70% because you had 98s more often than you had the one single 70. So that is a weighted average. They are used in a lot of areas: mixture problems, which is what we're going to be working a lot with, work problems, distance problems, I got a couple of those for you, and also some interest problems as well. Those are the main ones that you're going to see when we're dealing with weighted averages. So as an example, let's just say Hannah adds a 70% solution of an acid to 12 milliliters of a solution of acid that is only 15%. How much of the 70% solution should be added in order to get a 60% acid solution? I would suggest creating a table. Now, this is a little bit different from what your book has, but this is the way I prefer to do it. I think it's a little bit easier to understand. Notice that I have columns and rows. Each column deals with a certain aspect of my problem. The number of milliliters, the amount that I am using. I have a percent of each group, and then a total, in this particular case, the total amount of acid. As my 15% solution, I have a 70% solution, and then I have the final solution that I want, which in this case needs to be a 60% solution. If I take the 12 milliliters and I add more amount of a 70% solution to that 12 milliliters, that means my volume is going to go up. Instead of being 12, if I added 50 milliliters, then that means I would have 62 milliliters when I'm done. So I'm adding those two numbers together. I want a 60% solution, so I put 0.6 right here. And this is the amount of the milliliters that is actual acid, as opposed to water that is diluting that particular acid. So if I take the 12 milliliters and I know 15% of it is the acid, well, if I take 15% of 12, that'll give me the number of milliliters that is actual acid. I can do the same thing here with my 70% solution, except for multiplying by 0.7. And I can do the same thing down here where I have my total amount, which I'm not really sure what it is, but if I multiply by 0.6, it should give me the total amount of acid in my final solution. Now, what I do know as well is that if I take these two numbers here and I add them together, I should get this number right here. And so that is where I'm going to create my equation. So I have the 15% of the 12 milliliters plus the 70% of my unknown amount of milliliters that I'm adding to it should give me 60% of the total amount of milliliters that I have, which is going to be the 12 milliliters plus whatever I added to it. Distributing, that gives me 1.8 milliliters plus the 0.7x plus 7.2 milliliters plus the 0.6x. Combining my x terms, I'm going to go ahead and subtract 0.6x from both sides, subtract 1.8 from both sides. That gives me 0.1x equal to 5.4, multiplying both sides by 10, and I get 54 milliliters. So we would have to add 54 milliliters of the 70% solution in order to get a 60% solution. When I do that, I am going to end up with a total of 66 milliliters because I had 12 to begin with, and then I added an additional 54 milliliters, giving me a total of 66. Try this one there at your seats. This one's a little bit more difficult. Let's go through the process of how I would set up a table. I've got some information here. I've got blackberry tea that I'm trying to make, and I'm going to sell it for $25 a pound. So right here I have the $25 a pound for blackberry tea. I have dried blackberries, so just the blackberries cost $10.50 a pound, and the tea costs $35 a pound. And I want to make 5 pounds of, I want to use 5 pounds of blackberries, so I put 5 pounds here where my blackberries are, and I want to figure out how much tea I would need to add to it in order to get a mixture that is worth $25 a pound. So my 5 pounds of blackberries plus the amount of tea that I add to it should give me my total pounds of blackberries. I want the cost to be $25. If I take the total of 5 pounds times the $10.50, that gives me 10 times 10, or 10 times, that gives me 5 times the 10.5, which gives me 52.5. X times 35 gives me 35x, and then 5 plus x times 25 gives me 25 times 5 plus x. I know once again that these two being added together should give me the total amount. So that's what I'm going to set up in my equation. I've got the 5250 plus the 35x is equal to 25 times 5 plus x. Distributing that and then combining my terms, I'm going to go ahead and subtract 25x from both sides, subtract 52 and a half from both sides. That gives me 10x is equal to 72.5. Dividing both sides by 10 gives me an amount of 7.25. So I need 7.25 pounds of tea in order to make the wanted mixture. Go ahead and see if you can set up this table. I'll give you a moment. Just set up the table and then we'll work it out. If you set up your table correctly, you should have premium, supreme, and the blend as your 3 rows. And then in your columns, you have the number of pounds of each of those, the price per pound of each of those, and then the total amount of cost that is going to take for each of those. Now, let's start off. We have how many pounds of premium? So P here is my unknown, is going to be mixed with 2 pounds of supreme. So what I'm going to do is I'm going to put in a 2 for my number of pounds of supreme, and I'm making a blend. My premium costs $9.50 a pound, so I'm going to put 9.5 there. My supreme costs $11.75 a pound, so I put 11.75. And my blend is going to cost $10 per pound, so I put a 10 right there. The total blend is going to be the number of pounds of premium plus the 2 pounds of supreme, so that'd be P plus 2. When I multiply these two across, I get 9.5P. Multiplying these two across, that's going to give me the 23.5. And then when I multiply these across, I get 10 times P plus 2, or 10P plus 20 when I distribute. Now if I add these two in this column, I should get that third row of my column. So I have 9.5P plus 23.5 is equal to 10P plus 20. I'm going to go ahead and subtract the 9.5P from both sides and the 20 from both sides, giving me 3.5 is equal to 1/2 P. Multiplying both sides by 2 will allow me to solve for P, and that gives me 7. So I need to add 7 pounds of premium in order to get the mixture or the blend that I want for this particular problem. Now let's try one that deals with a distance problem or a rate problem. I'm going to do it a little bit differently than what I did with the others. The mixture problems tend to be a little bit easier to do the table the way I have it set up. This one, going to take a little bit different type of thinking. Diana is rowing a canoe. Her rate in still water is 6 miles per hour, and it takes her 3 hours to travel 10 miles round trip. If rowing at a constant speed, what is the rate of the current? So a couple of other things that I've included here is that distance is equal to rate times time, and also that if I were to solve that equation for time, I would get the distance divided by my rate. Now she's going 10 miles, but that's a round trip. So that means it's 5 miles upstream and then 5 miles back downstream. So my total distance is going to be 5 miles each direction. The rate at which she's going upstream is going to be slowed down, so her rate is going to go down by however fast the current is running. So if she can normally go at 6 miles per hour, if the stream is running downstream 2 miles per hour, that's going to slow her down to 4 miles per hour. However, on her trip back, she's going to be rowing with the stream, which is going to increase her rate by that same 2 miles per hour. I don't know if it's 2 miles per hour. I'm just using that as an example. But what we can do is I can take the amount of time is equal to the distance, which is 5 miles each way, divided by the rate. Well, her rates are going to be 6 minus r in the case of going upstream, and 6 plus r in the case of going downstream. If I add those two values together, I should get the total amount of distance and the total amount of time. In this particular case, her time is 3 hours. So her 3 hours is going to be the 5 miles divided by the rate going upstream, plus the 5 miles divided by the rate of going downstream. So I get this equation right here. Once I have that equation, we can use our regular process that we just learned in the previous lesson to solve. So I'm going to first of all figure out what values it cannot be. It cannot be either a plus or a minus 6 as the rate. And I'm going to multiply by my least common denominator, which is the 6 minus r, 6 plus r. When I do that, I end up getting the 3 times the 36 minus r squared. If you distribute this using the FOIL method, that's what you'll get. And then I have the 5 times the 6 plus r plus the 5 times the 6 minus r when I multiply by my least common denominator. Distributing, I get this. Combining my like terms and getting it into standard quadratic equation form, I can go ahead and now, distributing, I get this. Now, if I combine all my terms, my r terms actually go away. I just have my r squared that's left. And then if I subtract the 108 from both sides, I get negative 3r squared is equal to negative 48. I can then divide both sides by negative 3, giving me r squared is equal to 16. And then take the square root of both sides, giving me r being plus or minus 4. I threw out the negative 4 because I'm not going to have a negative rate of how fast she's rowing or anything like that. So it simply indicates which direction the river would be flowing at any one particular moment. So the rate of the water flowing is 4 miles per hour. Go ahead and try this problem. It is also a distance rate problem. So wind blowing at 20 miles per hour, the plane takes 7 hours to make a round trip of 2368 miles. What is the speed of the plane without the wind? In this particular case, we're finding the rate of the plane, not the rate of the stream or the wind. I do know that my flight would be, the rate of speed for the flight is going to be r plus 20 when it's going with the wind and r minus 20 when it's going against the wind, a tailwind versus a headwind. Each leg of the trip is going to be half of that distance because it is a round trip, so that means they travel the same distance roughly. So that's going to give me 1184. And when I set up my total time, which is 7 hours, that has to be the rate when it has a tailwind plus the rate over, or the distance over the rate of when it has a headwind. Clearing my equation of fractions, I'm going to multiply by r plus 20 and r minus 20, keeping in mind that the rate cannot be equal to 20 miles per hour, or else you wouldn't go anywhere one of those distances. So I'm going to multiply by my lowest common denominator, and that is going to give me all of this. Distributing out, I have the 7r squared minus the 2800. Distributing all this gives me this rather large equation, but fortunately a lot of it combines and cancels out. I can cancel out the 1184r, I can cancel out the 23680 on both, on this side, leaving me with 7r squared minus 2800 is equal to 2368r. I'm going to get it in standard quadratic form, and then in this particular case I tried to see if I could divide by 7, but this middle number here isn't divisible by 7, so I couldn't reduce it at all. And so I just went straight to the quadratic equation. You could also complete the square if you chose to do that. When I completed, or when I used the quadratic equation, I got an r value of negative 1.2, which isn't feasible that the plane would be traveling at a negative speed. And then the other one was 339.5. So my final answer is going to be 339.5 miles per hour is the plane speed in air without any wind. Try this next one. Going back to another mixture problem, we have Lily who ordered soup and salad for lunch. 10 ounces of soup and salad cost $3.30. How much salad did she get? And they gave some extra information. So let's set up the table first. When I set up the table, I'm going to have soup, salad, and then her entire lunch combined. I have the number of ounces, the price per ounce, and then the total that she would spend. So over here, she ordered soup and salad for lunch, 10 ounces of soup. So I'm going to put 10 where the ounces for soup is located. And the salad costs $3.30. So my salad is a cost of $3.30. or her, the total cost of her lunch. The total cost of her lunch was $3.30. So that's the soup and the salad, everything together gives us $3.30. How much salad did she get? So I have an unknown right there. The soup costs 15 cents per ounce, so I'm going to put 0.15 right there. The salad costs 20 cents per ounce, I'm going to put the 0.2 right there. The total lunch is going to be the 10 ounces of soup plus her salad, so I have 10 plus S. Over here, I don't know what that is right now, but if I multiply across, I'm going to multiply by 10, that gives me 1.5, and this is going to be 0.2 S. I know that these two added together should give me 3.3. So I have 1.5 plus 0.2 S gives me 3.3. I'm going to subtract 1.5 from both sides and then multiply both sides by 5 or divide both sides by 0.2 to solve for S. And S happens to be equal to 9. How much salad did she get? She got 9 ounces of salad. Try this one. All right, 16 cups of punch is 3% pineapple juice. Another punch is 33% pineapple juice. How many cups of the second punch is needed to add to the 3% punch to obtain a 20% apple or pineapple juice? So I'm setting up my table. I've got the first punch, which is 33 or 3%, the second punch, which is 33%, and I've got my blend, which is going to be 20%. I can go ahead and put those percents here, but I'm going to go through this. I have 16 cups of the 3%, so I'm going to put 16 right there. It is 3% juice, so I'm going to put 3 there. Another punch is 33%, so I'm going to put 33% right here. How many cups of the second punch will be needed to add to the 3% punch to obtain the 20% punch? So I'm looking for this amount right here. I'm just going to call it H. I need a 20% pineapple punch, so I'm going to put 20 right there. If I add the 16 and the H together, I can put that value right there. Multiplying these two across, you notice I didn't change these two percents. They're all going to be percents, so I don't have to change in the decimals. But if you did, it's not going to mess you up at all. You'll still get the same value. So I have 16 times 3, which gives me 48. Here I have 33 times H, and here I have 20 times 16 plus H, which if I distribute gives me 320 plus 20H. I know that these two cells right here added together should give me that third one, so that's where I set up my equation. I have 48 plus 33H is equal to 320 plus 20H. If I subtract 20H from both sides and 48 from both sides, I get 13H is equal to 272. Dividing both sides by 13 gives me 20.9. So they would need to add 20.9 ounces or cups of punch 2 in order to get the blend that they want. Brand A antifreeze is 40% glycol. Brand B is 60%. How much of each should be used to make 100 gallons of 48% glycol? This is a little bit different because I didn't give you either one of the amounts. So it's going to be a little bit more of a challenge, but it's not hard. Let's begin by setting up our table. If you set up the table, I've got brand A, brand B, and then our blend. I have 40% glycol for antifreeze A, 60% for B, and I need to know how many of each of these I need in order to get 100 gallons of my blend. So I'm going to put 100 gallons right there, and it is going to be 48% glycol. So this is all the values that I know. So what I need to do is I need to come up with one value that I'm going to solve for. I'm going to solve for A. How many gallons of A brand do I need? Now if I have a certain amount, let's just say 20 gallons of brand A, how much of brand B do I need? Well, I would need an additional 80 gallons in order to get 100. So I can take this piece right here and I can say, well, that's got to be 100 minus whatever I have here. So that's what I did. I have 100 minus A. Now I can multiply those across. That gives me 40A. If I multiply this across, that gives me 600 or 6,000 minus 60A. And over here, when I multiply, I get 4,800. I know that these two added together should give me that third row there. So that's what I do. I'm going to go ahead and combine my A's. That gives me negative 20A. If I subtract 6,000 from both sides, that gives me negative 20A is equal to negative 1,200. Multiply both sides by negative, it gets rid of the negatives there. Divide both sides by 20, and that gives me A. So I need 60 gallons of brand A, which would mean the other 40 gallons would have to come from brand B. Miss Skis has 40 milliliters of 25% solution, but needs it to be 30%. How many milliliters of a 60% solution should she add? So set up your table and then solve. All right, to begin, to set up the table, I have A, B, and then my blend. In A, I've got a 25% blend, so I've got 40 milliliters of that, so I'm going to put 40 milliliters here, 25% here. In B, I've got a 60% solution, and we need it to be a 30% solution, so I'm going to put 30% right here. I've got a 60% solution here. I don't know how many milliliters I need here, so I'm just going to use like a B or something to represent that amount. And then this blend is going to be 40 plus my B. If I multiply these two together, I'm going to get the amount of 1,000. If I multiply these two together, I get 60B. And then when I multiply these together, I get 30B plus 1,200 after distributing. Adding these two values here should give me the third value. So 1,000 plus 60B is equal to 30B plus 1,200. If I subtract 30B from both sides and 1,000 from both sides, I get a value of 30B is equal to 200. Dividing both sides by 30 gives me my value of B. I need 6.67 milliliters of B in order to get the proper blend for my glycol antifreeze. In order to get the proper value and proper solution that is needed for Miss Skis.